Okay, so I'm going to give a little demo here in my garage on how TxGraffiti works. Okay, so make sure I'm in the right place. So let's get there real fast. So let's go to the newest test version of TxGraffiti. Okay, so now we can just run this. Oh, what am I doing? Okay, so here it is. So this is TxGraffiti, I suppose a beta version of what I plan on releasing later this year. So TxGraffiti will make conjectures on graph theory invariants. So an invariant is a property that doesn't change on how you draw the graph. It's invariant under transformation. That's kind of a quick and easy way to think about it. So here are some numerical properties that you can compute on graphs. So we have domination number, total domination number, so forth and so on. So suppose we want to form a conjecture on the domination number. So let's do that. And for now, let's not focus on a structural property. And by running this, we see that we have both upper bounds on the domination number and lower bounds on the domination number. Okay, and these conjectures are sorted according to various heuristics that I've programmed into TxGraffiti that sorts them by what I would consider like the strongest conjecture. So for upper bounds, we see that we have this conjecture here. So this is the actual conjecture. So if a graph G is connected, then the domination number is at most the matching number. This is a score. It is, in a way, weighting how important the conjecture is. So this weight is higher than this weight. So this conjecture appears at the top of the list. So down here, we have lower bounds in the domination number. So if G is a regular graph, then the domination number is bounded below by what's called the residue. Okay. So this is one way of forming conjectures without specifying a specific property. So I don't want to remove any conjectures. So next, maybe I want to say, I want to specify structural properties of the graph. So let's look at the domination number again. And this time we're going to focus on a structural property. So then we have this collection of things that we can conjecture on. So graphs that are connected, well, all graphs are connected in my database. But we can specify as a graph regular, as a cubic, as a planar, all of these things. So maybe we'll focus on is it claw-free. So it takes a moment because it's now sorting the conjectures according to the heuristics I've programmed in. So it turns out that for an upper bound, it says that if G is a claw-free graph, then the domination number is at most the diameter. And you can see that this one way that I weight the conjectures, and there's several different ways to do this, but this one way is much higher than these other weights. Okay, again, this touch is a weight. So I've never seen this conjecture before, and it would be something to investigate. And that's the whole purpose of TxGraffiti, is to stimulate mathematicians into looking at relations and exploring them more. So I don't want to remove anything. That's a short demo on how to use TxGraffiti.